All right, guys, so continuing on, so we're going to graph this ln function. And remember, like I said, it's the same thing as a log, so we're still going to use, actually, no, let's list the transformations first. So anyway, +4 on the outside, remember, means we're going to do a vertical translation up 4. All right, and the inside is going to be horizontal translation, and plus you'd think it's to the right, to the positives, but really it's to the left. So left 5. Okay, and then last is 1/2. So 1/2 in the front is a vertical shrink or compression, either way you want to write it, by 1/2. All right, so now let's make our chart. So remember, ln is log, so we're still going to use 1, 0. Remember, it looks like LO for log. 1, 0, base 1, and the base this time is 2.7, right? Okay, and then we still make the same charts, right? Move our x values to the left. We're going to subtract 5. And then we got to shrink our y's, so we multiply by 1/2, and then we move them up 4, so we add 4. Okay, so 1 minus 5 is a -4. 2.7 minus 5 is -2.3, right? 1/2 times 0 is 0, plus 4 is 4. 1/2 times 1 is 1/2, plus 4 is 4.5. Okay, and then remember our asymptote for log or ln, L, think of it as an L, you extend it, it's going to be a vertical, and vertical lines are x equals, and they move either left or right. In this case, we move to the left 5. So we're going to be over here, left 5. Okay, all right, so -4, 4, and then -2.3, -2.3, 4.5. It's like in the middle here. Okay, and then this time, remember it's positive, so it's going to be going up. So we go along the asymptote, and then we just kind of like shoot out, right? So it's like an exponential on its side, right? All right, so domain. So remember, domain cannot be all real numbers because it doesn't go to these negatives here. The asymptote is stopping it. So it's -5 to infinity. I keep forgetting to write the asymptote. So x equals -5, right? The range this time, though, is all real numbers. -infinity to +infinity, right? So it's going down, and then this is going up, all right? So it goes everywhere. This is increasing this time, and it's always increasing. It never comes back and decreases. So we're going to say over all the x values, so over -5 to infinity, all the x values, it is increasing. X-intercept, we don't know, but remember, we can set it equal to 0 to solve it. So it's going to be something like -4 point. So you can see it like here. It's going to be -4 point something. We just don't know what. So we're going to set it equal to 0. So 0 equals 1/2 ln x plus 5 plus 4. Okay, so let's go through and solve this. So we're going to do subtract 4. Okay, so we got -4 equals 1/2 ln x plus 5. To get rid of that 1/2 in the front, we got to multiply by 2. Remember, that's how you get rid of fractions. So we're going to have -8 equals ln x plus 5. Okay, now that ln is by itself, now we can put an e down because e is what cancels out that ln. E to the -8 is left over here, and then x plus 5 is left over there. And then we'll just subtract 5, right? So let's type this into the calculator. So we have e. So e is where ln is. It's just second and then ln. So e to the -8, and then go over, and then we subtract 5, right? And we get -4.999. So let's do I know that's almost -5, but you cannot put -5 because that is the asymptote. So negative 4.9997. So I know that's kind of obnoxious, but negative 4.9997. Okay. So for y-intercept, well, we know it's going to cross the y somewhere, like 5 point something maybe, but we can't tell. So remember, we plug in a 0 to find the y-intercept. So this one's a lot easier. We just plug it into the calculator. So let's show you. So we're going to have 1/2, and then ln, crap, I'm so sorry. All right, let me put 1/2 in parentheses just to make sure. Okay, ln of 0 plus 5, which is just 5, right? And then plus 4 at the end. So we end up getting 4.8. So our y-intercept is 0, 4.8. Okay. All right. All right, and then end behavior. Remember, we can't say negative infinity to positive infinity because really it's -5 to infinity. And then still, that's just talking about the left side and the right side. The left side of the graph this time, this left side is going down, so we're actually going to write negative infinity. And then the right side is going up, so we're going to write positive infinity. All right, we're chugging through these. All right, so now we're back to exponential, right? So for exponential, I'm not going to say these over and over, so let's just write down the transformation. +1 is a, I'm dropping my stuff, is a vertical translation up 1. Inside with x, or up there with x, that is a horizontal translation to the right 3. And then a negative in the front is a reflection over the x-axis. Okay? All right, so remember, for exponentials, we use 0, 1, 1 in the base. So the base this time is a 2, right? This base number is a 2. Okay, so, and then to move our x values to the right, we're going to add 3. So, I mean, this should get second nature after a while because you do the same thing no matter what the function is, right? So to reflect it, we multiply y by negative and then +1 to move it up, right? So the new x values, 3 and 4. The new y values, -1 plus 1 is 0, -2 plus 1 is -1. And then remember, exponential has that horizontal asymptote, which moves up, right? That's a y equals, and you just look, oh, we moved up to 1, right? So I'm going to graph my horizontal asymptote here at 1. And then plot my points, so 3, 0, and 4, -1. Whew. And then, y'all remember this one, it normally, remember, it goes like this, but we've been reflected. So it's going to be that same thing, but it's going to be going down this time, right? So same sort of function, just going down because it's been reflected. All right, so remember, exponentials, we have negative infinity to positive infinity because this time there's no horizontal that's cutting it off, right? It goes left, this goes right, all real numbers. But the range isn't up here at all. So this one's kind of different. It's going down. So it's going to negative infinity, and then it goes all the way up to this asymptote right here, which is at 1. So this time it goes from negative infinity to 1, right? Because it's everything down here. This one's decreasing. Remember, this mirrors the domain because for all of the x values, it's decreasing, so it never comes back. We don't have to split it up or anything. X-intercept, you can actually see the x-intercept this time, so that's good. We don't have to calculate it. So the x-intercept is 3, 0. But for the y-intercept, we're going to have to calculate it. So remember, we plug in 0. Plug in 0. Okay, so let's plug in a 0. So -2 to the 0 minus 3 is just -3 plus 1. Okay, let's plug that in. -2 to the -3, and then plus 1. All right, is 0.875. So let's write that, 0.875. Okay, and then this time end behavior, it does go from negative infinity to positive infinity. And then we look left side, right side. Okay, so end behavior, that if you haven't noticed, the x part always mirrors the domain. So, but then we just kind of have to figure out the y part. So the left side, that's the side that's kind of leveling off. So that's leveling off at 1. And then the right side's going down. So we're actually going to write negative infinity. Okay? All right. Whew, that was a lot of graphing. All right, so now it says, name and graph two functions that are inverses. Describe the relationship between the two functions. So name two things that are inverses. Really, that's anything. Like, you can do ln and e. You could do log base 2 and 2 to the x. Log base 3, 3 to the x. Those are all inverses, right? So let's go, f of x is 2 to the x. Well, the inverse of that is log base 2 of x, right? So that's what we've been talking about, right? And so those are going to look opposite. They're going to be reflected over this y equals x line. So if we graph those, it's going to be reflected over that line. So remember, these don't actually have any transformations, so we can just graph our basic points. 0, 1, 1 in the base, so the base is 2 this time. So let me erase this line. I'll redraw it once I draw the graphs. So we have 0, 1, 1, 2, right? So our exponential function goes up like this. Okay, and then our log, remember, is just opposite. So our log function here, instead of 0, 1, 1, 0, instead of 1 in the base, it's base and 1. So 1, 0, and then base 1. Okay, and so you can see, remember, it like skirts along the asymptote and then goes up. So you can see, if I redraw that line that I erased, that it perfectly gets reflected over that line, y equals x. That's what inverses do. They get, because that's the whole thing, is that all the x's, all the y's, they flip. That's what it means to be an inverse. So describing the relationship, you can say it reflects over the line y equals x. Everything flips, right? So domain becomes the range. The domain and range flip. I cannot spell the word range apparently. The x-intercept now becomes the y-intercept, right? X-intercept and y-intercept. So everything just is flipping, right? So I'm not going to keep writing everything, but that's what's happening. Everything flips. Domain becomes range. X-intercept becomes y-intercept. You know, asymptote goes from y equals to x equals, right? Those flip. Everything flips, okay? All right. Oh my gosh, there's more graphs. All right, so so listing the transformations really quick. So this one has gone, has a vertical translation down 2. This has gone to the right 1. Oh, I should have written horizontal translation to the right 1, and then a vertical stretch by 3. Right? And so these are all the same. So I'm not going to like talk through it all completely, but we should kind of know, right? Our starting points, 1, 0, base 1. So our base this time is 8. Our x values are going to be moving to the right 1. And our y values, we stretch them and then move them down 2, right? So our new x values are going to be 2 and 9. Our new y values are going to be -2 and 1. And then remember, log is this horizontal asymptote, or sorry, vertical asymptote, and our vertical asymptote has moved to the right 1. Okay. And then we can plot these new points. So 2, -2, and then 9, 1. Okay, and so same thing, remember, it goes along the vertical asymptote and then goes up. And we know it's going to go up and not down because it's positive. All right, I will finish up the review in the last video.